It's a pleasure to present my next presenter. He actually loves cats, cars, and sailing. The 3 C's. Wait a second. Anyways, put your hands together for Marco Ceppi.
Thank you, guys. So I'm going to be talking to you guys about painless workload monitoring in the cloud with Nagios and Ubuntu, which is a whole lot of words thrown into one sentence. And I looked at this talk title and I thought, well, this isn't actually what I'm talking to you guys about. So if you're here specifically for this, I'm sorry. Really what I'm talking to you guys about is painless workload monitoring with Nagios and Juju. So for those of you who are probably like, okay, this sounds a little more interesting, we got rid of some buzzwords like the cloud. What I'm going to talk to you guys about is a problem that we've been encountering recently. So this problem is we've been working with a lot of high-performance computing, HPC, hyperscale kind of applications where we're dealing with a lot of services and a lot of servers at scale. And our problem is that tools that exist today can't really handle things at scale. When we start pushing past 100,000, 200,000 nodes, things like traditional configuration management tools, traditional other tools, all start breaking down. So we developed this tool to solve that problem. We said, well, this solves it for at scale, but we could also apply this to the everyday user. So what we decided to do is we build a tool around service orchestration. So service orchestration is designed to solve things, designed to help you manage your infrastructure and your environment at scale. Whether that scale be 1 machine or 100,000 machines. That's what we've kind of designed this tool to do. So with that, we built Juju. And Juju is what we call service orchestration. So somewhere along the line, we decided to show people where service orchestration lies on this whole scale of things. So a long time ago, we had bare metal, and that world was great. You had machines you could run applications on. Then we said, well, what about density? I've got a lot of extra resources that aren't being used, so we did virtualization. We came up with things like chroots and KVMs and LXC containers and the whole gamut of things, overt, and all these fun things that you can use to virtualize and slice up your machines. Then we took one step further. We said, what if we put an API in front of this and gave people this access to the cloud, which is really nothing new. It's just now your instances are a little more ephemeral. So we have cloud computing, and then people said, I have all these cloud machines, and I want to configure them, and I hate SSHing into 10 machines and running all these little scripts that I have. So we made configuration management, and that works out really great. And so the next level of this whole idea is service orchestration. I don't want to even have to log in to a server to run a configuration script, to supply variables, to set environment variables. I just want my services to do this for me. I want to describe a topology and have it executed. So that's what we've done. That's what we've encapsulated this idea of service orchestration with Juju. So how do we do this? How do we manage this in Juju? So much like Chef has Chef scripts, cookbooks, and Puppet has Puppet scripts, and Ansible has playbooks, and all the other gamut of tools have these very cool companion scripts. We also have a companion script to Juju, and that's called charms. And charms are very charming. They're very fun. Those of you who write charms become charmers. It's a very fun way to describe things. But what are really charms? Charms are executable white papers. So at the end of the day, what we're doing is we're going to experts that say, you deploy this service, and you deploy it at scale. How do you do that? We take all their knowledge. We buy the book on Nagios that's 500 pages long and describes everything you need to know about Nagios. We take all that and we distill it down into this executable sort. We just kind of wrap it in this nice little architecture. So we're creating this executable white paper, and that's what we're calling charms. And charms essentially act like Lego bricks. And the idea behind these Lego bricks is you can take a charm, you can just connect it to other services. And by doing so, you build an environment that you're describing, whether it's connecting MySQL to your PHP application, or whether it's connecting Postgres or Oracle to your Tomcat server. You're just snapping in these pieces together, and you're building an architecture. And that's what Juju does with service orchestration. So normally when I go to these conferences, it's at a conference where they're centered around a one kind of idea, like there's a Python conference, or there's another conference that does a language or an application. And monitoring is a very unique topic because monitoring is the solution, but the actual workloads people deploy in here range very vastly, from Windows workloads and administration to Linux workloads and administrations, from the whole gamut of languages and sorts. So I wanted to find an example to show you how this orchestration works. And I decided to choose one that most people know these days is Reddit. So if you don't know what Reddit is, and for those of you who are watching at home, don't want to type Reddit in the search bar, Reddit is a platform for sharing ideas and content. And unlike traditional bulletin boards, which are sorted linearly, this one's sorted by essentially votes. So the most popular content gets sorted at the top, and people can reply and continue a conversation there. So it's not a linear conversation between users around subjects. So Reddit's a great example because their platform is free and open source. So if I wanted to run my own Reddit install, I can just go grab their source and I can go run it somewhere. Reddit's big money bringer is their data. So they released their platform open source and their architecture. And what's really interesting about the architecture is they use a lot of components. These are just a few of them. Cassandra, RabbitMQ server for messaging, PostgreSQL for data store, Memcache for storage, there's GUnicorn for their data server, there's NFS for sharing data across a file system. There's a ton of components that build Reddit. And so because we have almost all these components already modeled in Juju, when I wanted to stand up Reddit, it took me a very short amount of time to get there. So I'm going to embark on a little bit of story. As I'm talking to you all, or talking at you all, you can go to this IP address and actually start using this Reddit install that I've stood up that the story ends with. So for those of you at home or watching this later, that's not there anymore. This is running in a cloud off my wallet, and the cloud's expensive. So I decided that I'm going to charm up Reddit, or I want to install Reddit. So the first thing I did was I Googled, how do I install Reddit? As most people do these days. And basically, this is what I got. The equivalent of this is the internet search results. I got forum posts. I got posts on Reddit. I've got posts from blogs. I've got posts from all over the world that told me all different ways to install and configure this software and replace Reddit with anything. If you're doing a Hadoop setup, try Google how to install Hadoop, and you will get a flood of different data from all these different people from different backgrounds telling you how to install and set up this service. So I went ahead and I followed a few posts, and I went and set up the scripts, and I read the READMEs, and I read the wikis, and basically I ended up cobbling together, after a couple hours' time, on this one little instance, a full Reddit stack. But it was tough to set up. It's not very repeatable. And at the end of the day, it was the equivalent of me just doing this, trying to hang a picture and ended up just putting things against the wall. It worked, but it's not repeatable. It's not scalable. It's nothing I can do to really repeat this installation, or to migrate it, or to stand it up somewhere else, or to give it to my friend. All this stuff is just there. It's in my brain, and now it's on the server. And until my bash history runs out, it's in my bash history. So what if we could make this a little easier? What if you could just do this? What if you could just run 2 commands and get Reddit running? So now I have Reddit running, but there's a ton of extra components. So let me go ahead and deploy those additional components. Reddit, RabbitMQ server, Memcache, Cassandra, GUnicorn, Postgres, NFS. All these are now deployed and stood up. So now I have a bunch of services standing around somewhere, whether it's on bare metal or it's in my cloud. I had these stand up. I've basically achieved what everyone could do today with simple configuration management. I have services running somewhere in an environment. Where service orchestration really shows its strength is I now want to make sure that everything knows where to go to each other. So I draw a map. I say Reddit is related to the Cassandra database. Reddit also goes to the Postgres database. Reddit needs the RabbitMQ server. Reddit needs Memcache. Reddit needs NFS. Reddit needs GUnicorn. And now I'm basically telling my infrastructure, this is what I want. Go make that happen. So what happens in the back end, and what really happens is these services are now communicating with each other. They're sending data. Postgres is saying, oh, hey, I see Reddit. Let me create you a database, a user, a password, and then it sends it directly to the Reddit service and says, here's your credentials. Do what you want with them. So I can program Reddit, the charm, to say, OK, receive credentials, write a configuration file. Something as simple as that. At the end of the day, what I'm doing is I'm orchestrating these services. I'm drawing out a topology, a network, an infrastructure, and I'm having Juju execute that for me. Juju is basically the language for me describing my network and executing these services. So all that's great. That was my next slide. OK. So what we're doing with these services is we're encapsulating what all the experts are doing. We're calling them subject matter experts. Basically, people who deploy Postgres in production constantly and scale Postgres, or deploy these services. We're encapsulating their brains in these charms. So you're saying, OK, well, how are you doing this? Like, what do I have to do this? This sounds interesting. I'm a little intrigued. I don't believe you. What am I doing? So charms are very loosely written, event-driven little pieces of code. So basically, there's a code file for every event that you model in your environment, like install, configuration changing, what happens when I'm interacting with different relations to different services. And you can write those codes in any language you want. Bash, Python, you can use and leverage Chef and Chef Solo. You can leverage Puppet or Ansible. You can leverage any tool you want. we're the framework that rides above configuration management. You can do whatever you want inside the charm to create this and to actually execute this. So with that said, monitoring. Really the reason I'm here. You guys are like, okay, great. What does that do with Nagios, though? Like, that's what I'm interested in for. So now I have Reddit running, and I have arguably a couple of services running. And now I want to actually make sure these run properly. So wouldn't it be nice if you can just do this? Deploy Nagios and deploy NRPE. Then describe, I need NRPE running on all of these services. And then I need NRPE to talk to Nagios so it knows where it is. What if we could just do that, and then Nagios knows how to configure itself, and NRPE knows how to read and ingest all the services and configure the services, and then suddenly we have the network topology that I have described in Juju, modeled in Nagios by using these relations and leveraging this service orchestration framework. So at the end of the day, that seems pretty good. It seems like it's not bad. So that's essentially what I'm selling you guys today, I guess. This idea that the tools you're using are boring. What you're really trying to capture in those tools is the expertise. You want to find what the experts are doing, you want to repeat the experts doing, whether you're reading a blog post and translating that into a shell script you carry around, or whether you're doing that and you're modeling it in a configuration tool like Chef or Puppet or Ansible, or you're doing it in something with Juju. That's what you're really after, is the expertise. And we're trying to capture and moderate the expertise and encapsulate them in services that you can reuse against any infrastructure. So this is when I do my live demo now, because people are like, all right, conceptually that sounds good, but prove me. Prove me wrong. Prove that you can do this. So without further ado, I will attempt to drive a demo. So since the cloud is fun and the cloud's a little slow, I went ahead and set up everything I've talked about except for the relation between NRP and these services. So I have Reddit running. Here it is, by the way, in case you were wondering. That IP address up there is kind of hard to see. There's a subreddit. I asked some coworkers to post in the subreddit so that it's actually data going in there. So I have Reddit running. It's using all these services. It's leveraging these Lego blocks. What I want to do now is I want to monitor it. So I've deployed Nagios. It's sitting here. It's just monitoring localhost, which is super good. I can get to Nagios, and localhost is running, which is all very good so far. The demo's going really well. What I want to do now is I want to connect these services together. So Juju has a command line tool, which you saw the text that we used earlier. It also has this GUI. Both these components, all of this that I'm showing you right now is all free open source software. So I'm going to go ahead and hide this over here. I'm going to move this little HTML canvas around. All right. So I'm going to click on NRPE. Let me zoom in a little bit, actually. Maybe you guys can see this a little better. There we go. So I'm going to click on NRPE. I'm just going to build a relationship. I'm going to actually click on Build Relationship. And I'm just going to say, OK, I want NRPE to connect to Postgres. So NRPE knows what it can connect to, because these charms are saying, these are the things that I can talk to. These are the protocols that I can speak. So notice how GUnicorn went black, because GUnicorn has no way to describe to NRPE how to actually monitor it. All these other services do. So I just connect NRPE to Postgres. And then I'm going to connect NRPE to Cassandra, and also to Memcache, and finally to RabbitMQ server, and why not NFS? Just going to connect to all these services that I care about monitoring. And then I'm going to go down here, and this is all transactional, so I can stage these changes. So basically, I'm going to commit these changes to my environment. I'm going to tell Juju, this is what I want, go do that. So down here at the very bottom, this corner, kind of hard to see, right behind my head, is a confirm button describing everything that I'm going to do. So I've done that. So Juju is now executing that in the environment. It's all event-driven, the environment itself. So if I go back over to Nagios, fingers crossed, this will actually work. So what's happening right now is NRPE is being deployed and installed to all the services and all the units within those services. These dots here, these boxes, are logical representations of service groups. Not single machines, but an entire group of machines. In this case, it's all one machine per service group. And I'll show you how that works for scaling in a bit. But NRPE is being attached to all those services. It's being installed. It's being configured. It's ingesting how that charm describes how to monitor it. So with the case of Postgres, it knows it needs to check for running processes, which processes to run. Postgres itself knows the size of the service it's on. The author knows that based on the size of my service and how many things I have running, these are my thresholds for warning and errors. It's attaching to to memcache, and Nagios knows that I need to check TCP on this port for this version to make sure it's responding properly. All this stuff has been described and encapsulated in that charm. And now Nagios is receiving all that data, NRP is being installed, and the configurations will be showing up in here in a few moments, depending on how slow or fast my cloud is for the day. So as these show up, I'm going to talk a little bit more about this, what we're looking at here. So I'll talk briefly about it. So we have these services, and these are all service groups like I mentioned before. So let me open up, for instance, the Postgres service. So on the right here, a little hard to see, a little cut off, it shows that I have one unit of this service. Each charm exposes a level of configuration. So you define the configuration once for a service group, and as you scale, as you move out, either scaling out or in, all that's retained across the services. So everything is eventually consistent with all the other services in the group, and that's how we manage these services at scale. So going back to here, stuff showed up. So now we have Cassandra, we have Memcache, we have NFS, Postgres, and RabbitMQ server, and the various checks that have been codified for those, all lined up and ready to run. Nagios will check them in due time, and hopefully they'll all come back green. And as I modify my environment, everything else will expand with it. So right now I have one unit of Postgres. While those services are waking up and getting checks, I'm going to scale my Postgres service out. So I'm going to here, I'm going to say, I'm going to add 2 units of Postgres, confirm, commit my change. Go ahead and do that. So now you notice the bar down here changes. So Juju's modeling a health, more or less a health of the service. So those bars will change depending on status. So I have one unit that's currently running, and I have 2 units that are coming online. So what's Juju doing is it's talking to my provider, it's provisioning machines, it's enlisting those machines within Juju, it's adding those services, it's running all the events that it needs to model. It's then executing any additional things. So the relationship between Redis being executed, that's all being consistent. And then NRP will be added to each of those units because I've described it in my topology, and that's how it will be. And in a few moments' time, when Postgres comes up, we'll see those additional units modeled here within the Nagios control panel, the Nagios services status. That is, in a nutshell, what we're talking about service orchestration and what we're doing here with Nagios. So where we go from here is this is a very highly opinionated view of what the author thinks should be monitored within your charm. So right now, you can go anywhere you want. You can download Juju for free. We support lots of cloud providers, from bare metal to containers. So if you want to run in little lightweight Linux containers, Amazon, Azure, any OpenStack install like HP Cloud, which is what I'm using currently, Joyance, DigitalOcean, and we're adding providers all the time for support. These charms will consistently run against all of them. So what you get is you get this expressed environment. You can basically model this, saying this is my production environment. You can download this representation. You can then give it to a developer who can run it on their laptop using LXC containers or using Vagrant or using something else that's lighter. They can model your production cloud in their system, play, hack on it, modify, and then present any changes back to you. You can model those changes then in production or in QA, et cetera. So what we're doing is we're trying to write a language for expressing these environments. We've scale tested Juju. Juju scales really well. We do install an agent. Everyone's always like, agents, no. But we do install very lightweight, compiled Go language written in Golang. It's very small. All communication within the cluster is done over TLS. So we've made sure we do security. We've made sure we validated that there's negligible impact onto the machines. We use Juju currently to deploy OpenStack. So I'm not sure if anyone here is familiar with what OpenStack is. It's a next generation cloud provider platform. Think of your own private Amazon AWS, more or less is what OpenStack is. Currently, to get an OpenStack running takes you about a couple weeks' time. You read the instructions, you do all this stuff, modeling. We have consistently demoed and showed going from 0 to OpenStack in 15 minutes. Fully scaled, high availability, secure OpenStack installs using tools like Juju. And then you can bolt on monitoring, you can bolt on logging. I just now learned this week about the Nagios log server, which is awesome. You can expect the Nagios log server charm from me very soon. Just bolting on logging on top of everything else. So that's kind of the idea that we're presenting with this, and that's how we use Nagios currently. Internally, we use Juju for everything. If you go to ubuntu.com, you're accessing a machine that's managed and deployed by Juju, and we also use Nagios to monitor all of our installs internally. using very similar methods as I've shown you today. So that's it. Oh, it looks like we got some couple things. Cassandra is a little busy. Looks like Postgres is, process count is critical. It's because people are actually using the site. These machines are very low in memory. I'm trying to save money. So they're all about 1 gig in size. Obviously, you wouldn't want to run Cassandra, a single unit of Cassandra on 1 gig of memory, let alone running Postgres on the same concept. But this is what you have here. So I'm going to wait a few moments for the cloud to react. Let me go back to my dashboard. So we're still waiting for those units to come up. Again, they will be in pending for a little while. Machines are being provisioned. Clouds are doing cloud-like things. So what we've described is, and I went to a lightning talk, and the lightning talk was great. It was noob to Nagios in 90 days. And I believe it was Sally Wright that was giving the talk, and I thought that was great, because that's basically what I had to do when I first learned Nagios. It took me about 35, 40 days. I was under pressure, a lot of pressure from the company at the time to get monitoring. We ended up having to monitor over 60,000 hosts in Nagios at a time when Nagios 2 was the big shiny. So we had a lot of problems there, but it took me a while to get up to speed with what Nagios was. So what we've done and what we're trying to model with Juju is noob to Nagios in 90 seconds. So that's kind of the concept we're selling here, is that, you know, a lot of sysadmins will say, well, I don't want to just pull something off the shelf and use it. If you've ever used any of the public forges, like Chef, there was a talk yesterday about using Puppet, they mentioned those forges aren't moderated. So review everything you use from these public forges. Charms are a bit different. We actually go and actively review and maintain charms for security, for sanity, so that you can take them and use them as an enterprise solution. But again, don't take my word for it. All of this code is GPL v3 or another open source approved license. So you can download the charm. You can look at the hooks. They're all in relatively simple language. So you can actually examine what's going on. And if you don't want to use Juju, you can at least leverage the knowledge that's recorded in them. Again, this is the idea behind this executable white paper. Don't use Juju, but at least use what the experts are doing. So with that, we're coming to a close of the talk. These are just some information for you. I'm happy to take questions. I'm happy to show other things. If you guys were like, well, deploy this. I'm happy to break live demos. I actually really do love demos. If you have anything you want to see modeled or any questions you have, please let me know.
Hi, I'm a command line guy. Are there textual interfaces for Juju?
Let's show you the command line. So I've got this over here. So everything we just saw a second ago was this beautiful GUI. I used to call it the manager view, and then we had full feature parity now in the GUI, so I actually use it a lot more because I'm lazy. But everything you can do, you can see with status. So I'm going to pipe this to less because it is a lot of YAML output. But basically what Juju will do will show you everything the GUI does from the command line. So this shows you all the machines that you have enlisted and running, all those dollar bills flying by my eyes. Then it shows you the services. So it basically understands here, slightly cut off, but you have Cassandra, the charm that's being used, the relations that exist within the infrastructure, and then how many units of that are running. So if I go ahead and jump down to Postgres, for instance, we should see a couple of units down there. There we go. So Postgres, it's got 0, 1, and 2 units are running. And then we see the rest of the charms, Reddit, et cetera, and all the relations are modeled there in Juju status. This comes out as YAML, as JSON output. And we just added a couple new features, which I don't have in this version, for doing more condensed outputs. Essentially, it would look like this. So we have this, which is probably one of the more popular ones, which is a highly condensed version of the view of the world. Your units, their state, if you are in error right now, the ports that are available, the IP addresses, et cetera. So everything I did in the GUI from the command line plus more, Juju help will get you going as far as what to do. It's structured very much noun action kind of, so it's all subcommand, kind of a Git command-like feel to it. Any other questions? Yeah.
2 quick ones. One, when you say AWS support, are we talking like VPCs, scaling groups, all that can be modeled using this?
So that's a great question. We started just supporting every cloud we can find. So we don't support a lot of the native features of clouds directly in Juju. But we've actually built this idea of a proxy charm which lets you communicate. So if you want to use ELB, you can just deploy this representation of ELB in your service, and then just basically put in your API credentials and what you want from ELB, and then you can relate it to your other services. We're looking to add those kind of things like how do I model storage, how do I model networking. Those will be adding in core in the next 6 months. Those will be coming out inside of Juju. But we don't directly support VPC at the moment. With the Amazon provider, we actually have something called a manual provider. Any node with SSH, you can use Juju with.
Okay, and the second one, if you create a layout for, let's say, Vagrant, and you want to use the same one on AWS, two separate layouts, or can you swap the underpinnings?
They're all interchangeable. What happens is, and I can show you actually what that looks like here. So let's go back to my GUI. There's a little export button down here. There we go. This downloads a YAML file. I'm going to open it up in gedit. Oh, please forgive me. This is essentially the static representation, and I can't increase font size because gedit. This is the static representation. All the configuration, all the scaling, all the relations are all modeled in here, and this can be ported across any Juju environment. This is the Juju language. Yes, great questions. Any other questions, things you want seen? There's about 215 services available for deploying right now. That's most of the major core components and a bunch of little extra ones. Like if you want to deploy Minecraft and run a Minecraft server, we got you covered. Yes?
So you kicked off two new Postgres SQL servers?
Yep.
And what actually did that? Or can you show the underpinnings of that?
As far as?
How they were deployed or using, what did you deploy it with? Did you deploy it with Juju?
Yes, those were all done with Juju. So everything I've done here, so what happens is when you run that Juju bootstrap command, which I showed earlier in my talk, let's go back a little, step back in time. This right here, this Juju bootstrap command, this is the world for Juju. So what you do is when you run bootstrap, it sets up a very small instance in that provider you're using. So Amazon, local, AWS, wherever, and that's the orchestrator node. Everything else from that point forward uses a WebSocket API to speak with the orchestrator and enlist its view of the world and retrieve its view of the world. So for those of you who are thinking immediately, single point of failure, you can actually scale the bootstrap node for HA and failover, and all that works appropriately. But when I clicked on the GUI and I said, give me 2 more units of Postgres, that went and told the orchestrator, we now need 2 more units, and it works to rectify that view constantly by pushing out events into the ecosystem. Is that what you were getting at? Sorry.
Yeah, does it do updates too? Say you wanted to change a com file?
Yes, totally. So if I went to, for instance, the good charm, for example. The Memcache charm should have some simple configuration options. So here it lists a bunch of things. If I want to change the connection limit, or if I want to manage different configuration attributes of the service, so the author who writes the charm then says, these are the configuration options I want to expose to the world. So it's not every configuration option, it's most likely the ones you want to modify. And you can add ones additionally if it doesn't suit your needs. As you modify those, it's again pushed into the event queue, the charm processes it and manages everything, and then makes it that state that you've described. So when I deploy Postgres, and it's red here, and we're going to pretend like it went green for a second because it's a live demo. The demo gods were not as pleasant to me today. But what happens essentially is those 2 units come up, Postgres is brought up, and then it replays every change I've described to it in the environment up to that time. So it gets all the configuration changes, it gets all the relationships that were added, it manages and cycles those. I think it's because I'm using a small instance. It does master-master replication across all the nodes, so it creates a cluster for you. That's the idea behind these service groups, and I didn't really talk about that. Terrible salesman. So what's happening with Postgres and what would have happened in MongoDB and these other data services that you can actually scale. As you scale MongoDB, it automatically starts, it automatically creates a replica set for all those services, all those units in that service. Same with Postgres, you get master-master replication. Cassandra, same thing. It sets up a quorum, it creates master-master replication. So this does clustering for you. All of that idea, all that concept of clustering is embodied inside the charm as code. And it's taken care of for you as the events are driven through the ecosystem. So that's what's happening behind here. So if we go back to the lovely terminal, which everyone loves, and I run Juju status Postgres. So there's a problem with Postgres, which I totally planned. I threw a wrench at everything. It says that the replication relation had an error. So at this point, I can go and investigate. I can view the log files. I can run commands to rectify it. I can make changes to the environment, effect change, and rerun the execution of the event cycle, and have it replay that, and then with the new data or with data I fixed, will be able to move past that error. So when stuff like this happens in the environment, when an event fails, we call them hooks. When a hook fails, it stops the execution of all the other queues. So it is an asynchronous environment, but there is only one event firing at a time per unit. So if we hit an error, the unit stops and says, I'm in error, I cannot proceed. So there's a chain of events that are being queued afterwards. Once you resolve the error, it moves forward from there. So if I were to say I fixed this, totally didn't, but let's say I did, I could just say, okay, I've resolved the error on Postgres unit 0. Now it'll continue firing the rest of the execution chain that was queued up if there was any events left over. So that's how Juju helps inform you what's going on in your environment, and it helps you to react to it. There's a slew of debug tools for checking logging, for interacting with the hooks directly, like a breakpoint in a command file. All that sort of stuff is rolled in here, Juju, to help you manage your environment, whether it's in dev or whether in production. Any other questions? Yeah.
Is there any way to, within Juju, to create another independent Postgres
Yeah.
cluster?
Yeah, so let's say you want to make another. So I'm going to use the command line for this example. I'm going to bump the font up a little bit so you guys can see it better. So you say, clear, Juju deploy Postgres, and I want to call it PSQL DB1. So that'll create an alias for it. DB1, sorry, Juju. It gets offended sometimes when I don't do the right formatting. What this will do is it'll take the exact code for Postgres, deploy it again, and it's just going to be called Postgres PSQL DB1 instead. So you can model several service groups, and that's actually what we do with the MongoDB charm. Every logic you need for MongoDB, if you're familiar with it, it's got these concepts of sharding and replica sets, and there's a config server, there's a Mongo server. All of that logic is encapsulated in the charms. The service groups change roles depending on the relations that are created to it. So you create a relation from a MongoDB service to another MongoDB service. You say this one's Mongos and this one's now shard. It'll then reconfigure those services on the fly. So the model of what the charm is doing, what the service is doing, is modeled by basically the relations that are created to it and the configuration the user is impacting upon it. And the roles are modified from there. So if we go back to the GUI, we got this running. In a few moments, the cloud will react, kick up a machine, install Postgres, and I've got a pristine Postgres separate from the second one that I have running. Great. Any other questions? Anything you guys want to see? Anything else you guys want to break?
I see how easy it is to set environments up, but what about like rollbacks? Like
Rolling back?
Like tearing this down and maybe setting it back up again, or what if I had to do like an upgrade?
Sure. So I'll answer those in lockstep. So the first one is tearing down is really easy. It's a little dangerous. You just destroy environment and everything's gone. With the upcoming features of modeling storage, so right now everything is running basically essentially on EBS-backed volumes, and they just kind of go away when you're done. So we're modeling storage, so you'll be able to actually destroy your environment, have your data persisted, stand up an environment, and then describe this is where the storage for this environment exists. So data integrity is something we take seriously. With the exception of the destroy service command and one that says terminate machine, we try to keep data integrity as far as possible. So if I just take this service here, I'm like, well, I don't really want NFS anymore. I could just destroy the service. The machine that service was living on will continue to remain in my enlistment, so I can SSH to it, I can bring data down, and then I can terminate the machine separately. That was the first one. I think the second one was something along the lines of, please refresh my memory, I'm sorry. Upgrading, yes. So we model upgrading in two different ways. There's upgrading the charm and upgrading the service. I'll give the Reddit charm as an example, because this one actually models upgrading the service. So in the configuration for this charm, and I'm going to see if I can bump the size up on this a little bit. Will it do? Scalable infrastructure stuff. So I can actually define the repository. And in this case, the revno could be any git ref. So it could be a branch, it could be a SHA-1 sum, it could be anything. So you can model that this repo using the production branch or the production tag or this tag, and then you can change that in lockstep by doing just configuration. Charms have a model of upgrading themselves. So you can actually upgrade the charm itself, which may or may not upgrade the service depending on how it's codified. But basically, we reserve upgrading charm for new features in the charm. I've added new configuration options or modified internally how the structure works. That's what these revisions are here. So this is local precise Reddit -version 1. I could upgrade this charm and it becomes precise / Reddit number 2, version 2. So the charms are all versioned independently as well, but they're typically separated from software to charm version. They're not coupled at all in that respect. That makes sense for you. Cool. Thank you. Any other questions? Things you want me to break? Comments, concerns?
Any cool cat videos on YouTube you want to show us?
Man, I got a lot. There's
Any personal
so
questions
many.
anybody would like to ask Marco? We
Yeah,
got a little
no.
time to kill.
like, what are you really doing with these cats? Like,
Do you
why
have
do you have
any
so many
words
cats?
of wisdom for everyone? Any closing statements?
Yeah, no.
I'm giving him a hard time. Ladies and gentlemen, put your hands together one more time for Marco Ceppi.
Thank you.